Okay, so in this class, we're going to have a wee look at 3D machining. So anything we've looked at to date has been 2D or like 2.5D machining, basically. So this is going to be relevant to your assignment because there is a fillet rad on the adapter flange part that will need to be done using 3D machining. Okay, so this is a lamp mold part. Okay, you can see this curvature here. It's also got a couple of holes in it. Now, in the past, when we have been importing, we would have saved the model as a DXF in SolidWorks and then imported as a DXF into AlphaCam. So in this case, we will import as a model. So when you go to Input CAD, you'll select SolidWorks and OK. Okay. Pick lamp mold. Active configuration only, just click OK for that. Okay, and you can see now that we have imported our 3D model. In the past, we just would have had green geometry and we would have had to set our block and create our block thickness. So this will bring it in for you. The only thing is you can see now there are no green lines, so there's no geometry. Okay. Another important thing to note is the datum must be in the center on the top of the part. Okay. And I'll create another video of that. It just so happens when this imported it was correct. But if you go to the edit tab, you can move it. Okay. And we'll cover that in another video. Okay, so the first thing I need to do is set my block. So along the bottom here, you can have grid references, which is quite good. Okay, so you can see it's 0 is the top. Okay, I want that to be +2 so I can machine off it. And we're sitting at around -60, I think. So the first thing I want to do is go to 3D tab, set materials. Okay, so I want to select all. There's no lines for me to pick. Okay, finish. Now I need to make sure that create rectangular material is selected. You can see now that that's created a block. I want Z top to be 2 and we'll go with -60. That's what it's shown here and click OK. So now you can see that I have a block around my part. Okay, so you can see there's still no green line, so I can't select anything if I want to go to my machining. So I'm going to select a face mill tool, my normal 63 mil. Okay, so you can see here that these are all grayed out. I can't select them. I can select manual toolpath. So if I go top view, I pick manual toolpath, levels and cuts. So safe rapid 50, rapid down to 4, material top is going to be 2, and I want my final depth to be 0. Okay, so I'll start somewhere out here and just do a manual toolpath, making sure there's a bit of an overlap there. Okay, and then okay, and escape. Okay. Okay, so that didn't work. Oh, there we go now. Press escape again. Okay, so you can see we have a toolpath. So if I go to simulation, I will see that it's taken 2 mil off the top as per what we would normally do. Okay, so these are all going to be grayed out because we don't have any green geometry to pick, but what we do have here available to us is 3D machining. Okay, so I'm going to select a tool and I'm going to select a flat tool. So we're going to machine this. See if I look. So we're going to machine down in this shape, basically in levels, okay? And it's going to be like steps, really. We'll use a large tool to begin with, large diameter 16, then maybe go down to 10, and the steps will get finer as we go through, and then we'll eventually use a ball nose or ball end cutter to get this curvature, okay? So if I select flat 16 mil, okay, and we have a flat carbide end mill, and I go to 3D machining, okay, so 3-axis, that's fine. So you can see here strategy, okay, so there's numerous different options. We're going to go with Z contour roughing, okay, so you can see here the steps that I was kind of talking about in this wee simulation, okay. We're going to click OK. So we come up with a similar screen to what we would have had with the 2D machining. Okay, so we want it to be contour and we want it to be climb mill type. Okay, then we go to levels and cuts. So safe rapid, we're going to say a 4. Our feed down distance 1.6. That's fine. We'll leave that. Maximum depth of cut, I'm going to say a 4. Okay. This is important here. Cutting order, we're going to go by level. Okay. So I'll explain by zone in class just so you're aware of the differences, okay? So then we want to go to the machining data tab. So XY stock to be left, we want that to be 1 millimeter, and Z stock to be left, we want that to be 1 as well, okay? And then let's see, is there anything else on this tab? No, I think that's it. Okay, so click OK and then pick all and finish. Okay, so now you can see this toolpath. So if I go to simulate, speed that up. So you can see it goes to each corner, starts to take a bit off, and it's just going in levels. So it'll go and it'll leave a step. It'll go to the next one, next level, and leave a step, and so on, okay, until it gets down to the bottom. Okay, so you can see there all of those wee steps. Okay. So now I'm going to use a smaller tool this time. So I'm going to select tool. Again, it's still going to be flat. I'm going to pick a 10 mil tool. Okay. And then I'm going to go to 3D machining. So this time I'm going to pick a different strategy. I'm going to pick horizontal Z contours. Okay. And click OK. So on the first tab then, XY stock to be left, we're going to go with 0.5 and Z 0.5. Safe rapid, we're going to say 2. Okay, then lead in, lead out, just leave the same machining data then. Okay, so we've got width of cut and cusp height. We're going to go with width of cut and we're going to leave it at 2.5. It's going to be climb. Okay, so cut between levels. Now this will become important. We're going to select it now. We're going to take auto off and we're going to say between 0 and -40. Okay, but this will become important for the assignment and I'll explain that in class. We're going to then go by level again. Okay, and the rest, those, we don't put in anything more or change anything in those tabs. Okay, and click OK. Again, pick all and finish. Okay. So now if we go simulate that. So we're starting from the top and we're going down round and we're starting to get more of that shape. Okay. So you can see there we still have steps. Okay. So stop and okay. So the next one then we're going to pick is ball end cutter. Okay. So ball. Okay, cutting solid carbide, and we have a 16 mil in Uri, so that's what I'm going to pick. And then we go to 3D machining. Okay, so our strategy is going to be constant cusp. Okay, and click OK. So stock to be left is 0 because this is our finishing operation. Okay. Lead in, lead out, lead the same. Is there anything there I missed on that one? No. Okay, so this one we're going to change to cusp height, and cusp height is going to be 0.3, or sorry, 0.2. Going to be climb. We're going to clip to depth. Okay, so it's going to go between 0 and -40, and we want to pick start cutting it inside. So that's going to cut from the top down. If we didn't do that, it would go from basically from here up, whereas we're going to start here and come down the way. Okay, click OK, all finish. Okay, so now if we run that. Okay, so this type of machining can take quite a while. Okay, I'll turn that down a wee bit. Oh, what did I do there now? That didn't work. Okay, so you can see we've started at the top. You can see we've got the ball end cutter. Okay. We're just going down around. Now, you're still going to have like little small ridges, and we'll go through that in class. It's not going to be totally smooth, okay? And you can kind of see that there. Okay. So we've got holes in each corner here. So you can see I was going to start to go around like that. Okay, so you can see there that in the simulation, you have these little ridges in places, and you can see that it's just done it by level. And it may not be that distinct in real life, but you'll still get a bit of that, and you'll be able to see a bit of that, okay? Okay, so if I stop that, okay. So I'll turn these off for a little second just so it's a bit clearer. So you can see that there are holes to drill as well. Now, we have no green geometry there, so we've no way of selecting those. Okay, so there is a way that we can extract the geometry from the model. Okay, so if we, let's see, go to solid model extract tab here. Okay, contour from picked edges. Okay, chord tolerance, just click OK on that, and I'm going to pick that, and I'm going to pick finish, finish. Okay, so now you can see there that I have green geometry, and I'll be able to select that hole. So I would just do the same thing again. Contour from picked edges. Okay. Finish, finish. Now you can do this one drillable hole extraction. Okay. And then pick the face. Okay. So that'll automatically work out what depth it is from the model. Okay. But it's probably better just to do this contour from picked edges and put in the depth yourself of minus Z, whatever it is, if it's a through hole, or say it's only going down 6 mil deep. Okay, so we now have geometry that we could pick those holes if we wanted to drill them. Okay, so so now you can see that these aren't grayed out anymore because I have green lines, I have geometry, so I could just go as normal, pick drill, go for spot drill. I'm not sure what diameter they are, so let's see, pick this. Yeah, and then drill machine holes.